I don't have any room in my car. I'll meet you there.
Oh.
Damn, I should have calculated if that was continuous.
Here's your route. I don't have any room in my car. I'll meet you there.
Oh, it looks like I'm continuous this time.
Yeah!
Yes, baby.
When Nick gave me my route and I crashed into a fence, that represented a discontinuity, where there was no point at C, and the function was discontinuous. But when I kept biking and continued on my route, that represented a continuous function. There are multiple types of discontinuities. An asymptote where the function goes on forever and never touches C. A step discontinuity where if x is greater than or equal to c, then 1, but if x is greater than c, then 2, and a hole, where the function has a hole missing where c is.
Go.
Oh my God, are you okay?
Give this to my kids.
You need to go to the hospital?
Lumpy dolls.
So this is our base form. We have f prime of x equals the limit as x approaches c for g prime of x over h prime of x. And this is our first practice problem. We got f of x equals the limit as x approaches 1 of ln x over x minus 1. And you plug in 1, so you get ln 1 over 1 minus 1. And ln 1 equals 0, and 1 minus 1 equals 0. And so that's what you want. It's the indeterminate form. And then, so you take the derivative of f of x, and you get 1 over x over 1. And then you plug in 1 again, so you get 1 over 1, which is 1, and then you have 1, so it equals 1. And sometimes you might get infinity over infinity, and you just treat it the same.
Yo, what happened?
I don't know. I just hit him in my car and he died.
He's dead?
Yeah.
What were you following the rules?
What rules?
The derivative rules!
Okay, so here we have our derivative rules, and the three ones we're going to go over are the product and quotient rule, the power rule, and the chain rule right here. So I'm going to start you off with the chain rule. We have g of h of x, and when taking the derivative, we have g prime of h of x times h prime of x. So how this works is first you start with taking the derivative of the outside of the equation. So in this example, the 7, we'll use the power rule here, it will go down in front, multiply by the rest of the equation, and then we'll decrease it by 1 up here. So it's 7 times 3x to the power of 6. And the next step is taking the derivative of the inside of the equation, which is the 3 of x portion. So here it turns into 7, 3 of x to the power of 6, times 3, which is the derivative of the inside. And when simplifying, we just multiply the 3 and the 7 right out here, and it gives you 21 times 3 of x to the power of 6. So moving on to the power rule, it's pretty simple. Here we have a times x to n, and it turns into n times a times x to the power of n minus 1. So in this example problem shows a little bit better. So we have 2x to the third, and the 3 will come right down here, multiply with the 2, and will leave you with 6x squared. Here is the product and quotient rule. They are pretty similar. The only difference here is once you set it all up, you have to divide by v squared for the quotient rule. Here I'll show you with these example problems. So we have 5x times 3x, and that will give you the u 5x, u prime 5. And the v will be 3x, and v prime will be 3. So here it's all set up. We have 5 times 3x plus 5x times 3. And that gives you 15x plus 15x. Adds up to 30x. And with this one, we have 5x squared times 2x. So the u for this would be 5x squared, u prime will be 10x, v will be 2x, and the v prime will be 2. So when we put it in the equation, we have 10x times 2x minus 5x squared times 2, all over 2x squared, which gives us 20x squared minus 10x squared over 2x squared still. And simplifying that, 10x squared over 2x squared will all go down to 5. And that's the derivative rules.
Sorry, sir, but I'm going to have to arrest you.
No, arrest me.
Hands behind your back, please.
Oh.
Both.
Oh.
Who is this?
Whoop whoop.
Someone just get booked.
I just got booked.
What's going on here?
I got booked.
You need to take him to the jail cell.
Where's that?
Oh my god. We don't have any more jail cells.
What are we going to do?
I have to design more with optimization.
I have 500 feet of fencing in order to build 5 cells. So that means we can put the prisoner in there and any other prisoners that we get. I'm going to call this length Y and all of these are Y and this length X. We don't have to do anything with this side because that side is the wall of the police station. So to use all of the fencing, we need to maximize the total amount of area by getting the dimensions of the cells. So to start off, you make this equation, which is the total amount of fencing with the sides. Then you solve for a variable. In this case, I solve for x. It doesn't matter which one you solve for, just whichever one is easier. And then we leave that alone for now because we have x. So we can substitute in that in the area equation, which area equals x times y. So now we put this in right here in that equation, and then you distribute in the y. And then after you distribute, you take the derivative of the equation and you get 500 minus 12y. Then you set that to 0 and solve for y. After you solve for y, you get 41 2/3 equals y. Then, because we already have an equation for x, we can use that equation and substitute in the value that we got for y, which is exactly what we did here. After you do that, you get 250 for the dimensions. So our jail cell would be 250 over here and 41 2/3 for each of these y values.
Good thing we figured out how to make your cell using optimization. Here's your food, maggot. Eat up.
Oh!
Damn, I wonder how much cereal I spilled on that maggot. Let's find out. Area and volume of a solid rotated around the x and y axis. There's 2 ways to do this. The first way I'm going to show you is the cylindrical shells method. Our equation we're working with is y equals x over 2 squared. As you can see, this equation is right here, and here's our cylindrical shell in the middle. Our equation to find the volume of this solid rotated about the y-axis is dv equals 2 pi r h dx. Now we know it's a dx equation because the thickness of the shell is along the x-axis. So then now we can substitute in for r. We know the radius is also along the x-axis, so we can substitute x in for that. And the height of the cylinder is along the y-axis, so we can substitute y in for that. So now we have dv equals 2 pi xy dx. Now we're just substituting in our original equation for y and putting everything in terms of x. So we have dv equals 2 pi x times x over 2 squared dx. Now you're going to want to simplify this before plugging it into Math 9. So you can simplify all this down to pi over 2 times x to the third, and then that's your equation. You can just plug into Math 9 And we know our limits of integration are 0 to 5 because the equation goes from 0 to 5 along the x-axis. And since it's a dx equation, you use x values. So when you're plugging into Math 9, you just plug that equation in, the simplified version, with their limits of integration, and it'll get you the right answer. To do it the long way and use algebra, you have to take the integral of this equation, pi over 2 times x to the third, which ends up being pi over 8 x to the fourth. And once you have that, you can plug 5 and 0 in for x and find the difference, and that will also give you the right answer. The next way I'm going to show you is the disk method. A little bit different, since this one's a dy equation and the other one was a dx equation. Here's our original function, as you can see again. Now this is a dy equation and not a dx equation because the thickness of the disk is along the y-axis. So our equation is going to be a little bit different. And this one, it's going to be dv equals pi r squared dy. And we know the radius of this disk is along the x-axis, so we can plug x in for r, since that's the radius. So we have dv equals pi x squared dy. And then, so to get x out of this equation, you have to solve for x. And it ends up being 2 root y. So you have to do that. You plug that in for x, since it's in terms of dy. So your equation you end up with is dv equals pi times 2 root y squared dv. And then that can be simplified down to dv equals 4 pi y. And then that's your equation you can plug in to Math 9. And since it's a dy equation, you look along the y-axis for your limits of integration. We see it goes up to 0, or it goes up to 6.25 and starts at 0. So it's going to be from 0 to 6.25 when you plug it into Math 9. To do it the long way, you take the integral of 4 pi y, which ends up being 2 pi y squared. And you plug 6.25 in, just like in the last one. You plug 5 and 0 in, you plug 6.25 in and 0 in, and find the difference and find out that the volumes are the same. Thank you.
Thank you. I really wish I followed those derivative rules.